So our topic this afternoon is DC circuits or direct current circuits under week 7 of the module General Physics 2. Our learning objectives are: first is to calculate the total resistance in the circuit with resistors connected in parallel or in series. Second is to simplify and analyze networks using Kirchoff's or Kirchoff's rules. Now, we need to review what is an electric circuit, what is a circuit diagram, no? To understand the problems in the examples. Electric circuit is a closed conducting path for an electron flow. Again, this is a closed conducting path for an electron to flow. So, walang electric circuit na, halimbawa, meron tayong source, tapos, ulit. Okay, so, a circuit contains a wire, a resistor, could be a load. Basically, kung merong switch and a source of EMF, simple circuit, no? So, kung ganyan lang, open yan, that is not closed, no? So, kung switch pa yan, kailangan pa yung isarado para maging closed conducting path for an electron flow. And voltage must be connected across the circuit to produce current. So kasi walang voltage na i-connect sa circuit, walang current. Kasi ito yung driving force para ma-move yung electrons. So yung circuit diagram looks like this. Generally, usually drawn with straight lines at right angles to each other. So we have a switch. Ayan. Switch, open switch. This cell for our source. We have an ammeter, symbol ng ammeter. This is an instrument used to measure electric current. And then we have a lamp. Or you can place in here, instead of lamp, resistors or other appliance. So let us differentiate DC from AC, no? So when the current direction in a circuit does not change with time, the current is called DC or direct current. Most of the circuits analyzed will be assumed to be in steady state with constant magnitude and direction. So like the one powered through a battery. When the current direction in a circuit changes with time, the current is called alternating current. So let's have the comparison of AC and DC. By definition, the AC voltage is the force that drives the alternating current between 2 points. While DC, the DC voltage induces this direct current between the 2 points. In symbolic presentation, we have a sinusoidal wave for AC, straight line linear for DC, and yung frequency depends on the country. So sa Philippines, we have 60 Hertz and DC 0. In DC is fixed in polarity. That is, mag-determine niyo yung negative at saka positive terminals. No? But then, sa AC, it reverses in polarity. DC can be steady or vary in magnitude. steady, kung na, for example, sa battery, example, 9 volts. Pero ma-vary din ito sa mga power supply. Maka-choose ka, 3 volts ba, 6 volts to 9 volts, na ma-vary ang value. But AC varies between reversals in polarity. Ang DC, steady value, cannot be stepped up, cannot be stepped down by a transformer. But AC can be stepped up or stepped down for electric power distribution. In DC electrode voltages for transistor amplifier, AC signal input or output for amplifier. Easier to measure is DC, easier to amplify is AC. Okay, so next we have this resistor. Alam mo natin yung capacitor. Capacitor is a device to store charge, no? Resistor naman is a device or it is an electrical component that limits or regulates the flow of electrical current in an electronic or electrical circuit. The word resist, no, opposes the flow of charges. It is a device, no, used in electric circuit to control flow of I. Now, ito yung mga samples, maraming types of resistors. Ito lang yung few sa mga examples. And then commonly, we have this carbon type resistors using color coding. So sa color code, sa colors, ma-identify agad kung ano ang value. So an instrument used to measure resistance, kasi yung iba hindi makita yung value, we have an instrument used called ohmmeter. Now, why is it a need to know, or bakit pa natin i-tackle itong resistors in combination? No? So why do we need to study the combination of resistors? Pareho yan sa, ang sagot dyan, pareho sa sagot, why do we study combination of capacitors? No? So a combination of resistance in an electric circuit can be used to provide a right amount of resistance in the circuit. So if a single resistor of that amount is not available, so we can use a varying combination, series man or a parallel man, or a combination of series and parallel to get the required value of resistance. That is, for example, if you want to replace a resistor of value 10 ohms, and then walang available na 10 ohms sa electrical supplies, electronic supplies. So, pero meron kang tig 5 ohms doon sa bahay. So, anong gagawin mo doon sa 5 ohms mo para maging 10 ohms? No? So, yan ang importance in studying resistors in combination. So, resistors in a circuit can be connected in series or parallel. The total resistance are equivalent, or RQ or RT, of a combined resistors depends on the individual values and how they are connected. So, for resistors in series, simply add R1, R2, and R3. For parallel connection, you have to find the sum of the reciprocal resistances. REQ of parallel connection is the reciprocal of the sum of the reciprocal resistances. Okay. So, for resistors in series, simple circuit ito, wherein we connect resistors in series, no? So, since resistors, unlike sa capacitor na, yung capacitor naka-indicate, sa capacitor kasi, naka-indicate yung longer and shorter leg. So, longer leg, yung positive, shorter is negative. Now, sa resistor, wala yan. Walang polarity. So, pwede ito i-connect pabaliktad. Na? So, connect lang. Connect lang ng connect. So, V You have R1, R2, R3, R4. Now, to find R equivalent, simply i-add. Now, halimbawa, yung sabi kanina na you need 10 ohm resistor. Tapos wala doon sa store, electrical supplies or electronic supplies. Pero meron ka sa bahay tig 5 ohms. Marami. Paano mo yan i-connect na magiging 10 ohms? Okay, simple lang. I-connect mo lang yun, yung resistors in series. Para ma-add yung 5 plus 5, dalawa lang kailangan para maging 10. No? So, ganun. Yung importance ng resistors in combination. Now, take note na in resistors in series, single path lang. Isa lang ang pwedeng daanan dito ng charge. No? So, isa lang ang daanan ng charge. Therefore, I total, whatever IT, yung I total ng circuit is equal to I1, I2, I3, I4, and IN kung maraming R's. While yung V total dito, merong potential drop dito. Merong V1 para sa R1, V2 due to potential drop due to R2, V3 is potential drop due to R3, and we have V4, potential drop due to R4. And to check, dapat i-total niyo yung V1 to V4, yung total must be equal to V total. Walang sosobra. At hindi rin pwedeng kulang. Okay, so example. We're given R1, R2, R3, 8, 3, 9, 10 ohms respectively, and V total is 60 volts. So what is the equivalent resistance of the circuit? Simply, kasi nakakonect ito in series, then follow the formula. Simply add. No? So 8 plus 3 plus 9 plus 10 is 30 ohms. Next is what is the current in the circuit? Add I for individual I in the resistor. So simply to find the current in the circuit using V total. So i-recall niyo yung formula ng Ohm's law. Huwag niyo kalimutan yun sa previous na lesson. That V is equal to IR. So to find I, simply I is equal to V over R. So kasi V total I total ang hanapin natin, we need the value of V total and R total. That our V total is 60, given sa problem, and R total, nakuha natin by solving. So 60 over 30 is 2 amperes. Now, again, kasi naka-series, constant ang I, automatically, I1 is equal to I2 is equal to I3 is equal to I4 and is equal to I total 2 amperes. Okay. So let's move to the next. So find the voltage in each resistor. So from Ohm's law again, V is equal to IR. So we need to find V1, V2, V3, and V4. So to find V1, simply I1 times R1. V2, I2 times R2, and hanggang V4, I4 times R4. So since pareho equal yung I, kasi nakakonect in series yung resistors, then pareho ang I. Next, i-multiply ninyo yan sa R1, R2, R3, and R4. Multiply. 16, 6, 18, 20. And to check kung tama yung solution ninyo, kasi resistors in series, i-add ninyo yung all V's. No? I-add ninyo lahat ng voltages or potential drops sa mga resistors. The total must be 60 volts. Na, so, pag ganito, ma-check na niyo, alam niyo na perfect kayo sa assessment. Now, next is resistors in parallel. Sa parallel. Pag isipin niyo yung parallel, ibig sabihin merong common points, no? Like this one, merong common points at point A na nakakonect yung R lahat ng R. Merong common point at D. Similar yan dito, though magkaiba yung pagkasulat, pero lahat connected. Si R3 connected sa source. Si R2 connected sa source. Connected sa source din yung si R1. No? So pareho lang ito, dalawa. So to find R equivalent or R total is to add. No? So ibig sabihin R equivalent is equal to 1 over R1 plus 1 over R2 plus plus 1 over Rn. Now, since connected ito sa source, di ba? Lahat ng R's nakakonect directly sa source. Therefore, V is constant in resistors connected in parallel. Therefore, V total, whatever V source dito, equal yan sa V1, V2, V3. Vn. Kung maraming resistors. And to find I total, simply add I1, I2, I3 to In. Okay, so let us analyze that or put that in our example. So a circuit with resistors, with 3 resistors connected in parallel, as in the figure, R1 is 10, 3 is R2, 20 is R3 in ohms, V total is 60. 60 volts ang total, V total. So find the equivalent resistance of the circuit. So use the formula and then find R total or R equivalent. Sige, use your calculator. In your calculator, pindot ninyo yung 10. Tapos merong function dyan na 1 over x kasi scientific or x to negative 1 or x negative. Tapos plus, add 30 by 3. Then pindot yung function 1 over x. Add 20 function of 1 over x. And then equal, press again 1 over x. Well, sige, kung may calculator, si Princess, merong calculator. What about Carl? Sige, practice. Wala ka dala dyan. Sige, check daw, Princess. Makuha mo? Okay, madali lang ito pag meron kayong calculator. Okay, sabihin natin nakuha na ninyo. So the approximate value of R total is 2.07 ohms. Next is to find the voltage on each resistor. Kasi nakakonect ito in parallel, automatically without computation, kuha agad ninyo yung V1 to V3. 60 volts kasi constant ito sa circuit pag yung resistors connected in parallel. So, check na tong B. Next, what is the current in the circuit and I in each resistor? When we say current in the circuit, we need to consider VT and RT. So, from V is equal to IR, I, therefore, is equal to V over R. So, RV is 60. Divide natin yun ng approximate value of RT, 2.07. So, yung value naman dito sa I total is approximately 30. That's between ranges from 29 to 30. But then, again, use your calculator to have an exact value. Next is I in each resistor. Ibig sabihin, kunin nyo yung I1, I2, I3. To find I1, you have to substitute V1 and use R1. V1 over R1 for I2, V2 over R2 for I3, V3 over I3. So, nakuha niyo yung value sa I1, 6, I2, 20, I3, 3. To check again, if your answer is correct, then add I1 plus I2 plus I3. The total must be approximately the same or equal sa value ng I total. It's approximately 29, or sa example dito kasi wala tayong na round off na value, so I total therefore is 29 ampere. May decimal tayo dito kasi nag-reciprocal tayo dito, no? Anyway, may mga allowance for error man. Okay, so may mga connections like this. May mga connections like in the diagram, wherein we have R1, R2, and R3. R1 is series with parallel R2 and R3. So in this type of circuit, all you have to do is to simplify. I-focus mo na kung saan yung complicated na part. So in this figure, the complicated part is R2, R3 connection. So since nakaparallel, then use resistors in parallel. So paano yung kunin yung resistors in parallel? R total or R23 is equal to 1 over 20 ohms plus 1 over 30 ohms. Paano yan? So use your calculator again to solve for R23. So 10 reciprocal plus 30 reciprocal. The answer is 12. The answer is 12 ohms. Therefore, if you connect 20 and 30, connect na in parallel, bababa yung value. Mas mababa pa sa 20, no? Kasi you added reciprocally. Now, our EQ therefore is 12 ohms. And R1 is 38 ohms. Now, to find for the R total in the circuit, simply kasi si R1 naka-series with REQ or R23. Therefore, i-add lang nyo ito. 38 plus 12 is 50 ohms. Again, pag mga nakakombine na yung series parallel resistors, hindi na ma-identify as series lang, hindi rin parallel lang, combination pa. So all you have to do is to focus kung saan point doon yung which part of the circuit is complicated. And doon kayo magsimula to simplify. No? So like in our example. Next, we have Kirchoff's rules. Now, many complex circuits, such in the diagram, ito, at saka ito, that cannot be analyzed with a series parallel techniques developed in series and parallel combination of resistors. There are, however, two circuits analysis or rules that can be used to analyze any circuit, simple man or complex. Pero kasi hindi natin ma-identify series or parallel, we need to follow the rules, no? So these rules are special cases of law of conservation of charge. Ito, so number 1. And law of conservation of energy. the number 2. So the rules are known as Kirchoff's rules or Kirchoff's rules. After the inventor Gustav Kirchoff in 1824 to 1887. Sa dalawang rules ito, summation I equal to 0 at any junction and summation V equal to 0 at any loop. Again, dalawang rules lang ito. I-observe natin. Summation I, meaning add all I, or add all currents equal to 0, or current entering is equal to current leaving. And the second, summation V equal to 0. This is loop rule under conservation of energy. So this is valid for any closed loop. So what is junction or branch point? This is a point where 3 or more conductors meet. Balik tayo sa diagram. 3 or more conductors meet. 1, 2, 3. Dito naman 1, 2, 3. So this is the junction. Ito yung point, common point ng 3 conductors combined. No? Like this one. 1, 2, 3. Okay, so yan. Pwede rin ito. 1, 2, 3. 1, 2, 3. Okay, so yan ibig sabihin ng junction. Okay, so nabigay na yan. Next, meron tayong sign conventions na gagamitin in solving Kirchoff's rules, in using Kirchoff's rules. Traveling around a loop from A to B, so yung travel from A to B, travel yan, at sa kapareho sa direction ng I, so yung IR product natin, because V is equal to I times R, ang sign convention natin dito is negative. Pag magkasabay itong direction ng I at saka sa travel, again, negative ang IR. Pag opposite yung I, for example, traveling tayo, this is traveling from A to B, so yung direction pa right, I is to the left, so opposite, therefore our IR product is plus. For an EMF, source of electromotive force, the travel is from A to B. So, to the right ang arrow. Dito tayo mag-focus sa terminal ni EMF. Ano yung last na plate na matapakan? Positive ang electromotive force. Sa D, traveling from left to right, from A to B, to the right, ang last plate na natamaan is negative. That's why the sign of epsilon is negative. By the way, in 9 minutes, maputol tayo. Reconnect lang kung hindi pa tayo matapos. So we have here an example. We cannot solve this one using series or parallel formula. But this can be solved through the Kirchoff's rules. Now, what we have to do first is to identify ano ba ang unknown dito. Kasi pag meron kayong tatlong unknowns, kailangan niyang tatlong equations. Kung isang unknown, isang equation. Kung dalawang unknowns, dalawang equations needed. So, this is for analysis purposes lang. Kasi sometimes sobra talaga yung magawa ninyo na equation than the number of required value or unknown values. No? Okay. So, let us analyze. At point A, ito yung point A. Summation I, this is summation I equal to 0. Ang ibig sabihin nito, I entering. What are I entering is equal to I leaving. So, at point A, what are I entering? Isa lang. Si I1 lang entering, leaving I3 and I2. So, ma-present natin yan as in this presentation. So, I1 is entering equal sa I2 and I3 leaving. At point B naman, dito yung point B. Ano ay entering dito? We have I3. Si I3 papunta yan dito. I3. Isang I lang. No. And then si I1, leaving yan. So I2 plus I3 entering equals sa I1 na leaving. So we have the second equation. Next is to sum up. Wala na ibang junction dyan. So we have to sum up V equal to 0 at any loops. So focus muna tayo sa loop number 1. Closed loop. Sarado na loop. Ito. 1. Ito yung loop number 1. Ito. Okay. Yan ang loop 1. That's why I labeled it 1. Okay. So, let us analyze. Pwede kayo magsimula sa R1, R2, or sa V1. Now, ito yung start ng travel. Out tayo sa positive ng V1. That's why we have positive here. And then, observe na same ang travel natin dito sa direction ng I. That's why we have negative I1 R1. Same ang direction papunta dito, pababa. That's why we have negative I2 R2. Okay, so next loop, dito. Okay, again, you can start at R2 and end sa V2. Start sa R3, mag-end sa R2, mag-start sa V2, mag-end sa R3. So, depende sa inyo saan kayo magsimula. Okay, start tayo sa I3. Same ang direction nito. Therefore, same ang direction. Therefore, we have a negative I3 times R3. Negative ito ha. Okay, correct na lang. And then, next, we cross from positive to negative. So, ang sign ng electromotive force is negative, V2. And then, opposite tayo sa motion o sa direction ng I. That's why we have plus I2 R2. So, that's summation V ng loop number 2 equal to 0. Next, outside loop. Dito sa outside loop. Okay. Sa outside loop, meron tayong dalawang source dito, sources and R's. So it's up to you kung saan kayo magsimula. No? Basta ma-end yan before. Basta ma-end, ma-close ninyo yung loop. So halimbawa, start tayo sa V1. So we cross from negative to positive. That's why we have a positive V1. The next, same ang direction. So negative ang I1 R1. Next, same ang direction ng travel sa direction ng I, negative I3 R3. And then, baba tayo, we cross from positive to negative terminal sa V2, and we have negative V2. Okay, so yan. To illustrate you the summation ng I equal to 0 and summation ng V equal to 0. Now, in our analysis, we came up with 5 equations. Equations ito. No? Okay. Example tayo. So we are given a diagram. In 3 minutes, iputol tayo. Pero reconnect lang. Okay, so given diagram, we have this 24 volts and 3 ohms. Source of EMF, epsilon. And then 2 ohm resistor, 4 ohm resistor with I3. So wala itong label actually. Ako na naglagay ng I. It's up to you. Kayo na rin maglagay ng I. Now, if it happened na magka-negative yung I ninyo, kung magka-negative ang I ninyo, ibaliktad lang nyo yan so to correct your direction, your assumption, no? Sa direction. Okay. So, again, a label. Meron tayong I1 para sa 3 ohm resistor, I2 para sa 2 ohm resistor, and I3 for 4 ohm resistor. And then, analyze at junction A, we have I1 entering, I2 entering, and I3 leaving. Ito. Next, at junction B, ano yung entering? We have entering I3. Ito, entering I3. And leaving I2 and I1. Okay. Okay na. So, mayroon tayong dalawang equations dyan. Next is to analyze at loop 2. Ay, at the outside loop. Dito tayo sa labas. Mag-analyze. Dito. Okay. Nagsimula tayo sa B. We cross from negative to positive terminal. So, last terminal na maapakan is positive. That's why we have positive 24. And then next resistor sa 4 ohm. And 4 ohm and 5 amperes. 5 amperes, that's I3. So 4 negative I3 times 4. Substitute 5 times 4. And the next, eto, 3 ohm with I1. 3 ohm resistor with I1. Okay, tapos equate that to 0. So in equating to 0, is 24 minus 20 is 4 minus, nagiging 4 minus 3I1 yan, equal to 0. So I1 therefore is 4 over 3. That is equal to 1.33 ampere. Next is that at junction B. Junction B dito na point na to. We sum up I's, no? So, ano yung ibig sabihin doon? Junction B. I3 is equal to I1 plus I2. Gamitin natin yan dito. So that I3 is equal to I1 plus I2. Galing yan sa ano yung entering dito. Entering is I3. Entering is I3. Leaving I2 and I1. So to find I2 is I3 minus I1. Then, substitute the value of I3 and I1. I2 therefore is 3.67 ampere. At junction B, ito yung kanina nakuha. So I entering at junction B is I3 and out, leaving at point B are I2 and I1. So to find, since I1 given, I3 given, kailangan natin kunin yung I2. So I2 therefore is the difference I3 minus I1. Now substitute yung value, we have 3.67 amperes. Now for the inside loop, kasi our task or the problem asks us to find the EMF. Ito, EMF value. Unknown yan kasi. So, sa inside loop tayo, and we have to sum up voltage equal to 0. Dito yan. So, ito yung path natin. So, mag-cross tayo from negative to positive sa source of EMF. That's why we have positive epsilon. And then minus I3 by 4 ohms. I3, R3. And then minus pa, I2 and 2. I2 and 2. At saka wala na. So, simplify. Since epsilon ito, transfer lang natin itong dalawa sa right side. Naging 5A. 5A is equal to 5A times 4 is 20. 3.67 times 2 is 7.34. So that is why the value of epsilon in the circuit, kawawa naman ito si Princess. So that is why the epsilon is equivalent to 27.34. No? So again, we have to sum up V equal to 0 sa red loop. No? So mag-start tayo sa epsilon minus I3 R3 minus I2 R2 and equate that to 0. The next thing is to solve for epsilon. Simply I3, ma-move yan sa next side, ma-change yung sign, times R3 plus I2 times R2. So that is how we come up with the value of epsilon. Okay. So hoping na-follow niyo yung solution. For the lesson summary, a resistor is an electrical component that limits or regulates the flow of electrical current in an electronic circuit. So we have different types of resistors. An ohmmeter is an instrument used to measure resistance. And of course, do not forget that an electric circuit is a closed conducting path wherein the flow are number of electrons, and there should be a source of electromotive force. There should be a voltage in the circuit. Kasi pag walang voltage, walang current. Okay. So in series resistors, the constant is I. So ito yung constant. To find for R equivalent, ito yung formula. To find for V total, ito yung formula. In parallel naman, since connected in parallel, merong common points. No? So yung voltage ang constant. This is how to find for the equivalent resistance and how to find for electric current. In Kirchoff's rules or Kirchoff's rules, this can be applied to a complex circuits, no? Those circuits that you cannot identify if it is series connection or if it parallel connection, no? So ito yung gagamitin ninyo. Dalawang principles, dalawang rules lang ito. Summation I equal to 0 at any junction, and summation V equal to 0 at any loop. So sa travel sign convention, pag magkapareho, kasi mag-travel tayo from positive to, from point A to point B to the right, ganon. So pag magkapareho yung travel direction at saka I direction, then we have a negative IR. And pag opposite naman, positive ang IR. Sa sign ng electromotive force, when you cross from negative to positive, ano yung last na terminal, maapakan ninyo, madaanan, then yun ang sign ng EMF. So traveling from A to B, kung ano yung last terminal, yun ang sign din sa EMF doon sa equation ng V. So, end na tayo. So I would like to say thank you so much for your interest in attending our virtual class.